In this problem, we're given the universal set, which is the set of numbers from 1 to 8, and then we're given sets A and B. And we're asked to determine the set A prime union B prime, all of that together, intersect the set A union B prime. So in order to solve this problem, we're really going to follow order of operations, just like you did when you used to calculate arithmetic problems. But before we get to that part, what I'll do is I'll create a Venn diagram. And you can do this if you find that it helps you to solve these problems. So maybe it helps you, or maybe you prefer not to do it, but if you find it helps you, then I would go ahead and do it. So I make a Venn diagram. This is a really shabby Venn diagram, but that's all right, good enough. Okay, so I have set A and set B, and I look at what elements do they have in common. Well, they both have a 1 and they both have a 2. So I put that, or those two elements, in the intersection area of the Venn diagram. Then I look at what elements are in set A but not in B, and that is 5, 7, and 8. Then I look at what elements are in B but not A, and that's 4 and 6. And are there any elements that we haven't written down yet? Well, there's just the 3. So the 3 doesn't belong in either set A or set B, and I put it out here. Now, a lot of times people will say, well, 3 is in the universal set, but obviously the universal set has 8 elements, so everything is in the universal set, but people like to call this outer area of the Venn diagram the universal set, which is really not correct. And I'd rather you didn't say it, but, you know, if you got to do it, you got to do it. It's not really going to ruin your life. So, but just realize if you say it, but just don't mean it. So just say to yourself, well, I know it's not really the only part of the universal set, but I'm just calling it that because I really don't have a good name for it other than elements that aren't in set A or set B, which takes a long time to say. So that's what's up with that. All right, so now I've got my Venn diagram worked out. So now it comes to the order of operations part of this problem. So I look at the expression and I want to determine this set, which is quite long. So I'm going to start with the first set of parentheses and work inside of there, and I just determine what is A prime. So A prime is anything outside set A. Now once I have this Venn diagram, it's a lot easier to identify those elements. There's 3, 4, and 6. Kind of changed color there. And I'm going to erase those marks. Well, this isn't going to work super well. What do we have? A 4 and a 6 and a 3. Okay. So A prime is 3, 4, and 6. Now I think I know what I can do to make this a little better. All right, let's try this. B prime is the set of elements that are not in set B. So remember that set B is this set. It's everything inside the circle. It's not just 4 and 6. It's the whole circle of B. So it's 1 and 2 and 4 and 6. So what is outside that set? Well, we have the 3 and 5, 7, and 9. 5, 7, and 8. All right. So 3, 5, 7, and 8, and that's B prime. So the next step, clear this up, the next step is to find A prime union B prime, and then I'll have everything inside that set of parentheses. So let's do that here. A prime union B prime. So what I'm finding now is the set of all elements that fall into either of those two categories. So everything from A prime, so we need all of 3, 4, and 6. And I need everything from B prime, which is 3, 5, 7, and 8. I like to call this the spaghetti pot, and then you're throwing everything into the sauce, like ragu spaghetti sauce. Remember the commercial? It's in there. So everything is in there from either the first set or the second set when you union two sets together. So that means we have 3, 4, 5 from set B prime, 6 from A prime, and 7 and 8 from B prime. All right, so that's the set A prime union B prime. And that's the first tricky one to come up with. It's a little complicated, but we're just unioning together this set with this set. So throw it all in together. And if you have doubles, like with the 3, you just throw it in once, because we're just trying to say what's in there. All right, so that set of parentheses is done. So now let's move over to the other set of parentheses. And in the other set of parentheses, we have A union B. So that's kind of the same thing that we were just doing. We're doing a union. So we're going to throw in everything from A and also throw in everything from B. So that's 1, 2, 4, 5, 6, 7, and 8. Because every element from 1 to 8 falls into either A or B or both. Well, that's the 1 and the 2. Except for one element, and that's the number 3. That's the only number that doesn't fall into either of these two sets, which is handy because the next thing we're going to do is find A union B prime. So we say, what is the opposite of A union B? What is the complement? What elements are in the universal set but not in A union B? And that's just that one element, 3. So now I have the first set of parentheses, A prime union B prime, and now I'm going to intersect that with A union B prime. All right, so down at the bottom, last one, A prime union B prime. Intersect A union B prime. So what is the intersection? I'm going to circle these in red. What are the two sets we're looking at? What are they? Okay, here's the first one. We're going to intersect that, A prime union B prime, with A union B prime. So intersection means what do they have in common? So what is in common? Well, there's only one element here, and that's the element 3, and it does appear here as well. So the only element in common is the element 3. And so that is our final set. And that is the correct answer here. So we want 3 for our final answer. All right, that's the end of that problem.